This conference will now be recorded.
So in the last class, we started with multithreading. The main use of going with multithreading is to increase the performance of application. And whenever we want to create a thread, what we need to do? Just we need to create a class which extends thread, override run method. And we have to invoke run method only by using start. We have to create object of your thread class. And using this object, when you call start, it's going to create a thread and invokes internally run method. And we have seen the methods of thread class like current thread, set name, get name, set priority, and get priority. Today, let us go with one more example to understand more of threads. Multithread table. So we have created threads package. Right click on threads package and say new class multithread table. Now in this, let us create a class thread x extends thread. Now override the run method. Public void run. Take the current details of thread. How to take current details? Thread t equal to thread dot current. Now, so what is the need of taking current details? When you want to change the name or priority, then we call this method, else not required. Now let us change the name t dot set name to threadx. Now in this threadx, we want to print the numbers from 1 to 10. So to print for int I equal to 1, I less than or equal to 10, I plus plus. Here we will say t dot get name. So when you say t dot get name, what it returns? Threadx, a separator colon, then the value of I. So the output will come threadx colon 1, threadx colon 2, like that, threadx colon 10. Now in main thread, create object of threadx t1 equal to new threadx. Then invoke run method only by using start here. So when you say t1 dot start, it is going to invoke this run method. Now run this piece of code. See here. So when you run, we are getting the result, see threadx 1 to 10 here. Now see what you have done in this code. We have just created threadx extends thread, overridden run method. And in run method, we are taking current details of thread and changing the name to threadx. And we are printing from 1 to 10. So in main thread, we have created object of threadx and we have invoked run method using start. Now when we run, simple the result threadx 1 to 10 here. Now let us create one more thread class. Class thread by extends thread. Class thread by extends thread. Override run method. Now take the current details of thread. Thread t equal to thread dot current thread, and let us change the name to thread by. Now take a for loop which starts from 10, I greater than or equal to 1, I minus minus. Then we'll say t dot get name a separator colon and the value of I. So how it comes? Thread by 10 to 1 here. In main thread, create object of thread by t2 equal to new thread by and set t2 dot start. Understand here, the result is important to understand more. See, when we run, how we are getting, see, it's going to thread x 1 to 2, means when run method of thread x is getting executed, it is even coming out, and see, observe, it is allocating time to thread y here. It's coming out and allocating time to thread y. Again it is coming out and again it's allocating time to thread x. Again coming out and allocating time to thread y. Means in the case of multi-threading, when a method is getting executed, in between it can even come out and allocate time to other methods, which is proved by seeing this result. Let me run the code again to see the proper output. Let us run the code. See here, it is going to thread y, and again it's going to thread x. Again it is going to y, again x, again y, again x, again y. Like that it's continuing. Means your CPU is going to run method of thread x, and even in between, before the method is completed only, in between it is coming out and allocating time to thread y. Sometime for thread x, run method of thread x, sometime for run method of thread y, sometime for main method of the class here. So in the case of multi-threading, whenever we invoke a method, in between CPU can even come out and allocate time to other methods, which is proved by seeing this output. Clear, all of you? Now, instead of start, if I go with run, then see how many times you run, the output will be same. Thread x 1 to 10, thread y 10 to 1. How many times you run, the result will be same, because when you go to run method of thread x, until the total run is over, it won't come out at all. Again, when you say t2.run, it will go to run method of thread y. Until the total run method of thread y is complete, it won't come out. So it's an ordinary program. So whenever you want to create a thread, we have to create a thread only by using start method. Only by using start method. And one more point, if I invoke start method twice here, so already we have made the thread to go to runnable state. Again informing go to runnable state once again. Go to runnable state once again. So this will go with an exception here. That is illegal thread state exception. So when we invoke start method multiple times, what will happen? What is exception we get? Illegal thread state exception. Right? Now, once you print thread x colon 1, we want to make the thread to go to block state. So whenever you want to make a thread to go to block state, we use the method sleep method. We call which method? Thread.sleep of 1000. Means 1000 milliseconds. Means for 1 second, the thread will go to block state. And sleep method throws interrupted exception, a checked exception. We can surround with try catch block. So whenever we call a method, if the method is throwing some exception, we have to call the method in between try and catch block. Similarly, once we print thread by colon 10, we want to make the thread to go to block state. We'll say thread.sleep of 1000. Just keep mouse pointer on error and surround with try catch, checked exception. Caught exception sleep method throws interrupted exception. Now see when we run how the result will come. Slowly it's going to display. Thread x colon 1, thread x goes to block state. CPU will be free. It's allocating time to thread y. Again thread y goes to block state. CPU is free. It's allocating time to thread x. Like that slowly it's going to display. So what is the need of sleep method? To make a thread to go to block state for given interval of time. Sleep method. When sleep method is invoked on a thread, the current thread will go to block state for the give an interval of time. Like example, if you say thread.sleep of 1000, here 1000 milliseconds, means for 1 second the thread will go to block state. Then one more note, when start method is invoked on a thread multiple times, then it throws illegal thread state exception. Right? So any questions, anyone? Now let us see how to create a thread using runnable interface. Creating threads using runnable interface. So first of all, let us understand, when we are able to create a thread using thread class, what is the need of runnable? In what situations we use runnable? Let us understand. If we take class A, with some code inside, and if you are creating class B, extends A with some code inside. Now we want to make this B class as thread. Then can we say here common thread here? Not possible, because in Java a class can extend only one class. If you try to extend multiple classes in Java, this will go with error, because does not support multiple inheritance. But the requirement is we want to make B class as thread. Then the solution is we have to take class B, extends A, and we have to say implements runnable. Now, when a class implements an interface, we have to override the methods of this interface. And in runnable, how many methods are there? Only one method run. So we have to override run method compulsory. So when you extend thread class, it is optional to override run method. Compiler will not give any error if you are not overriding run. But if you implement runnable, we have to compulsory override run method. So what is the point when to think of runnable interface? If a class extends another class, and to make this class as thread, the class should implement runnable interface, else runnable interface, as Java does not support multiple inheritance. One more point, ensures that run method is overridden. Let us understand this with an example code. Right click on threads package and it's a new class runnable demo. In this, let us create a class thread implements runnable. See, whenever we say implements runnable, we are getting error here. So what we have to do, we have to override run. See, just keep mouse pointer on this error. See, it's saying C. The type thread must implement the inherited abstract method run. So here, if you just click here, add an implemented methods, the method will be overridden here. So what is this @ symbol is? This we call annotations added in Java 5 version. Okay, so more elaboration, like we are just by seeing this @ override, we can easily know that it's a overridden method. So more about annotations we'll discuss in the next classes also. It's a very simple to understand, but for now just remember, whenever we see @ they are overridden methods. Now, so in this run method, go with some logic, any logic. So just I want to print from 1 to 10. So you are just printing from 1 to 10. So the main objective is how to invoke run method of threader. That's the main objective here. Coming to main method, create object of threader t1 equal to new threader, and we have to invoke run method only by using start. So when you say t1.start, see we get error because in threader there is no start method. In Runnable also there is no start method because both contains only one method, run. But the rule is we have to create a thread only by using start. But there is no start method here. Then the solution for this code is, since start is a method belongs to thread class, create object of thread class, and invoke start method using thread class object. Now see when you say t.start, see the output what we get? No output. Because since you are referring to thread class object, when you say t.start, it will go to run method of thread class. It will go to what? Run method of thread class. And what I mentioned yesterday, run method of thread class is empty method. There is no code inside. But the objective is we want to invoke run method of threader. Then the solution is, to the constructor of thread, we have to pass our runnable object like this one. T1 object we have to pass like argument to the constructor of thread class. Now since t is referring to t1, now when you say t.start, it will go to run method of threader. Now see when we run, we get the result here. So when we go with the runnable, just one line extra we should write, create object of thread class, to the constructor pass your runnable object and invoke start method using thread class object here. So this one line extra when you go with runnable. Clear everyone? Any questions? Let us move to the next one, and this is very, very important. That is synchronization. So let us understand what is this synchronization using a diagram. Let us consider we are having a bank account. So we are having a bank account with a balance of 5,000. Now, X is going to access this account. Y is also going to access the same account. Then, when two or more customers access the same account, what type of account we call? Joint account. So this is a joint account. Now let us suppose at time t1, X checks balance. time t1 x checks balance. So what is the balance here? 5000, right? So what is the balance? 5000. At time t2 x withdraws. So whenever we say withdraw, let me say 1000. At time t3 y checks balance. What is the balance now? 4000. At time t4 y withdraws, which is 1000. Like that, they are doing the transactions. At time t12 x checks balance, which is 1000. At time t13 y also checks balance, which is 1000. At time t14 x withdraws, which is 1000. At time t15 when y is trying to withdraw, it says insufficient balance. So just now it has shown to y that 1000 is balance. Immediately it is saying insufficient balance. So y will get confused what is happening. So what we are expecting, what the user is expecting, that is not happening over here. So this type of confusions, we call it as concurrency problems. So what you are expecting, if you are not getting, we call concurrency problems. So why we get this problem, let us understand. If you go with the method like void make withdrawal, the amount which you want to withdraw. In this method, here we are going with some code for check balance. And some code for withdraw. Right? Now, let us suppose this is a multi-threaded application and CPU has given time to X thread to enter into this method. CPU has given time to X thread to enter into this method. So X has entered into this method and X has checked the balance. X has checked the balance. So balance has been checked by X. Now since it is multi-threaded, now CPU has given time to Y thread to enter into this method. So Y also has entered into this method. So Y also has checked the balance. So Y also has checked the balance here. Now CPU has given time to Y X thread to go to the remaining piece of code. So X thread has executed this withdraw piece of code. So X has withdrawn the money. Now CPU has given time to Y thread to enter into remaining piece of code. So when Y enters into withdraw, it says insufficient balance. That's the problem here. So the solution for this problem is simply we have to use one keyword. Synchronize it. That's it. Solution of synchronization is very simple. We have just use a keyword synchronize it. So when we use synchronized keyword, when X enters into this method, until the total method is completed, Y cannot enter. Then when Y enters into the method, until the total method is completed by Y, X cannot enter. Means only one thread is running inside the method. So when only one thread is running inside method, then there won't be any concurrency problems. So simple solution is we have to just use synchronized keyword. So what is this? When two or more threads access the same resource, means here the bank account, same resource, then there is a chance, we are not saying every time, there is a chance of getting concurrency problems. Synchronization is used to avoid concurrency problems. If someone asks you how to avoid concurrency problems, means by using synchronization in Java. Synchronized keyword is used for synchronization. Which keyword we use for synchronization? Synchronized keyword. Okay. Synchronized keyword can be used for a method or block of statements only. Synchronized keyword, we can use it for a method or block of statements only. Like example, so if you are having a method PPP, if the complete method is having congruency problem, make the complete method as synchronized. So this we call synchronized method. Now, if you are having a method QQQ, if you are having a method, and in this method, let us suppose it goes with 100 lines of code. Let us goes with what? It goes with 100 lines of code. Now, and let us suppose only these 10 lines of code. Out of 100 lines, only some 10 lines of code is having concurrency problem. So if you make the complete method as synchronized, performance will be degraded. Because whenever we say synchronized, no multi-threading. Only one thread will be running. So when you are having problem with only some piece of code, make that lines of code as synchronized. Synchronizer of object. The object which is calling the methods. Right? This only we call synchronized block. Very important statement. In a synchronized context. So when I say in synchronized context means method or block, only one thread will be running, which degrades the performance of application. Which degrades what? Performance. But when you go with software applications, which is more important, correctness of application or performance? Out of these two features, correctness and performance, which is more important to us? Right, correctness is more important. Because if your software application is giving results very, very fast, but wrong results, then there is no use of your application. Because correctness is more important than performance. So in order to achieve correctness, some places we need to lose performance. That is a place where we use synchronization. Right? Any questions, anyone? Now let us move to the last one, very important, inter-thread communication. Let us suppose we are having thread 1, which is doing a task. Once the task is completed, we get the result. We take thread 1 and we do the task. Once the task is completed, we get the result. This result want to be used by thread 2. Thread 2 want to take the result value. Now, Let us suppose when thread 1 is doing the task, before the task is completed only, thread 2 is taking result value. Then we get wrong results. Because the task is not totally complete, before the task is completed only, thread 2 is taking result value. So we get wrong results. So they have to communicate now. Thread 1 has to inform thread 2 that I am doing the task now. Once the task is completed, when the result is ready, we'll inform, then you take the value of result. So that concept only we call inter-thread communication. How to do is, it is done using wait, notify, and notify all methods. How inter-thread communication is done means using which methods? Wait, notify, and notify all methods. Then these methods belongs to object class. Remember, not thread class. The topmost class of Java hierarchy, object class. These methods belongs. Then what is the use of this method is, when thread 1 is doing the task, thread 2 should not take result value. So what we should do? We have to make thread 2 go to block state. How to make thread 2 go to block state? By using wait method. Then when the result is ready, we'll inform thread 2 to come back and take result. How to inform? Notify or notify all. So when wait method is invoked on a thread, the other threads, remember, the other threads will go to block state. Until notified using notify or notify all methods. Then what is the difference between notify and notify all? Simple difference. If there is only one thread in block state, we can use notify or notify all methods. But if there are multiple threads in block state, we use notify all. So for multiple threads, compulsory we have to use notify all. One more very important point. These methods, what do you mean by these methods? This wait, notify, notify all. These methods need to be used in synchronized context only. These methods need to be used where? In synchronized context only. Else, if you are not using, it will throw illegal monitor state exception. If you are not using, it's going to throw what exception? Illegal monitor state exception. Now, let us understand all this using a program. Interthread development. Main method. In this, let us create a class thread sum extends thread or implements runnable. Anything you can take. Now here, take a data member sum and override run method. The task what we want to do is, we want to find the sum of 1 to 100. How to find sum of 1 to 100? Take a for loop for int n equal to 1, n less than or equal to 100, n plus plus. And we'll say sum equal to sum plus n. So this for loop will find sum of 1 to 100. Now coming to main thread, create object of thread sum. Create object of thread sum. Now we have to invoke run method. How to invoke run method? ts.start. So when you say ts.start, it will go to run method. It will go to run method. Now, once it goes to run method, it will find the sum of 1 to 100. Now, coming back to main thread, we'll print the value of sum. Sum equal to ts.sum. So who is doing the task? Thread sum is doing the task. Who is taking result? Main thread is taking result. Now, when we run the program, see the output what we get? We are getting 0. But what is the correct output? 5050. 5050 is the correct output. So, but we are getting sum as what here? 0. Sometimes even you may get this result also. Sometimes even you may get correct result also. Okay. Sometimes even you may get some other number also. But in our case, in my system, I'm getting 0, which is a wrong result. Now let us understand why we are getting 0. When you run this program, which threads will be in runnable state? First main thread, then TS thread. First main thread will go to runnable state, and when you say ts.start, TS thread will also go to runnable state. Now can you guarantee out of these two threads, which thread will execute first? No guarantee, right? Which I discussed yesterday. Our work is only to push the threads to runnable state. But for which thread your CPU is going to allocate time, that is not in the hands of programmer. So here we are having main thread and TS thread. And let us suppose if CPU has given time to main thread first. Let us suppose if CPU has given time to main thread first. So this line of main thread will execute. Then it is going to take some value as what here? 0, because this code is not yet executed. This run method not yet executed. Before your CPU has given time to TS thread, it has given time to main thread. When it enters into this line, it is taking some value which is 0 default value of sum. Now the objective is this line of main thread should not get executed until the for loop is completed. Until the total for loop is completed, this line of main thread should not get executed. So what we should do? We have to make main thread to go to block state. How to make main thread to go to block state? By calling which method? ts.wait. So when you say ts.wait, the other thread, who is other thread? Main thread will go to block state. When main thread goes to block state, this line of main thread will not get executed. And say we are getting error because wait method throws interrupted exception. You can add throws declaration, checked exception. There. Now when I should inform main thread to come back to runnable state, when I should inform once the for loop is completed, means once the task is completed, we'll inform main thread to come back. How to inform? Notify or notify all. That's it. Now see when we run, we are getting exception, illegal monitor state exception. Because what I mentioned, whenever we use wait and notify, we have to call these methods in synchronizer context like this. Synchronizer of the object name, which is calling wait method. Then notify also synchronizer of this, because we don't know which object is going to call this method. So to represent current object, what we use? This. Now see when we run, we get result 5050. How many times you run, we get the correct result. So this only we call interthread communication. How to do interthread communication? Interview question, very important. Using wait, notify all methods. Right? Any questions, anyone? So please practice this compulsory. The only difficult topic in core Java is multithreading. You have to recap 1 or 2 times to understand more. And tomorrow we'll go with a new topic and very, very important one. This topic we use more in our projects. That is collections. Collections are very, very important. Almost in all projects we use this collections concept. So tomorrow, day after tomorrow, we discuss on collections. Yeah. Thank you all.